Good afternoon, Black Hat. Thanks for coming. There is something in software that we've all just been living with for a really long time. At this point, I think it's not much of an exaggeration to say that open source dependencies pretty much run the world. Wouldn't it be nice to be certain about where they all come from? Well, at GitHub, we've been working on Provenance for NPM over the last year. And we're excited to share it with Black Hat because we feel like people here at this conference will understand that a world where you can know the provenance of software is going to be a world that has a little bit more of that extremely valuable commodity in security, certainty. So I want to start out by polling this enormous audience and asking the question, if you were walking down the street and you were super hungry and you saw this burger just sort of sitting there, like you're out there on the strip outside of Mandalay and you're so hungry, you're not starving, but you're so hungry, and you saw this and you thought to yourself, you know, I'm a human being and I need food to survive, and there's food, it's just sitting on the ground. Please, show of hands, who would lean down and pick up this mysterious hamburger from the street and start to eat it? Oh, wow, we got a couple takers. Fantastic. OK. Well, for the rest of you, these next questions are maybe going to be irrelevant. But for the most part, and hardly anybody wants to. So let's see if we can do better. How about this one? It's nicely wrapped up. It's just sitting there. However it got from the grill to the street, it's probably been well taken care of, right, with this beautiful wrapper. So for this one, show of hands, who would eat this burger? A little bit more reputable. Oh, wow. Several of you. Awesome. OK, very brave. All right, but for the most part, I'm seeing what I expect, right? Paranoid security professionals unwilling to trust the random food they find on the sidewalk. All right, maybe we can do better than this. How about this stuff? It's got the imprimatur of a widely known and indeed perhaps beloved brand. It's coming with not one but two hamburgers. They're together, they're wrapped up. We've got French fries. You're used to seeing French fries. There's some contextual stuff here that you understand. So show of hands, who would eat this highly reputable food? OK, a few more takers, but still pretty suspicious crowd. How about this question? When you sit down to make yourself a brand new software masterpiece, and you know in advance that it's going to be full of dependencies to do hard or annoying or boring things, i.e. you're going to be pulling functionality, executable code into your masterpiece, written by randos on the internet, how do you make the decision about what to use? I would posit you're probably making some kind of heuristic gut check choice, right? You hear about some libraries, you think about what they do, and you say, OK, well, I need some functionality that does X, Y, Z. Let me go and find something in that vein. Maybe you've heard about something that does this kind of thing. You go and you find the source code, and you start asking yourself some questions. Hey, does it have a lot of issues? Are people addressing issues on a regular basis? How fresh are the commits? How many stars? How many forks? Are there releases? Are those releases stale, or are there regular cadence? This is a great way to evaluate source at a gut check level. And of course, you should do things like subject it to analysis. But we all go and we make these kinds of decisions as we start out, and that's fantastic for source code. But the problem is when we go and we start to bring these into our builds, in the overwhelming majority of ecosystems, we're not actually going to the source code. As a Black Hat speaker, I get to make a big, gigantic statement, a very general one. That's just part of the contract. And so I will make mine here, which is that the single biggest problem in information security, all up, is implicit trust. And when it comes to the management of software dependencies, that problem rears its head in this gap between the source code repository, where something originates as a piece of code that you can evaluate and that you can do that gut check on, and the registry of record, where in the overwhelming majority of ecosystems you are actually building from. There is no ironclad binding from one to the other. Forever, we have just been assuming that whatever we find in the registry of record definitely matches the thing with the same name that we went and read about in the source repository. So we have all been, for all of these years, just eating hamburgers right off the ground. That's a problem that we at GitHub feel like we can fix. And we have been working on a solution to start trying to fix it for the world's largest registry of record, NPM. To talk a little bit more about what we have built and how it all works, I'm going to turn it over to Zach, and I'll see all of you in a few minutes.
Thanks, Trevor. So in the next 20 minutes, we're not going to be able to solve this problem for the entire software industry. But we can tell you what we did for NPM and how you might use this technique in your future work. NPM is the registry of record for JavaScript. And as you can see, there are billions and billions served. And you know what comes with a lot of users? A lot of attackers. We've picked some of our favorite supply chain attacks from the past couple of years here. But rest assured that daily bad actors are attacking the NPM registry and, by extension, NPM users, which include most of the software ecosystem. There's a new security capability now in the NPM registry called build provenance. We launched a public beta of this feature in April of this year. And since then, over 1,000 packages have adopted building with and publishing with provenance. 70 of which NPM considers to be high impact because of the number of monthly downloads they have or the number of other packages that depend on them. This is an example of what NPM provenance looks like, and we'll dissect this screenshot a little bit more in a second. But first, maybe just a little bit of a more formal definition. What does build provenance mean? Again, remember, we're trying to cross this gap of trust. We want to tell you exactly what is in the package. So here this means a link to the source code and also a link to the build instructions. Crucially, these links are verifiable. They are non-forgeable. Additionally, we want to make sure that you're aware of a specific asterisk here. We aren't saying that just because a package has provenance that it is inherently secure. We are giving you the links to follow and investigate the source code and the build instructions to make your own risk determination. We can't stop people from putting malware in the packages using this technique, but we can ensure that you have access to the source code or the build instructions to find that malicious behavior. All right, let's dive into the screenshot in a little bit more detail. So on the left side, we list out what cloud CI/CD platform the build occurred on, and we also have a link to the logs of the build. On the right side, we have a link to the source code, and we're not talking about a user-contributed link to the README, or a user-contributed link to the repo in the README. This is exactly what commit the package contains. Similarly, for the build instructions, it's not just any old link. It's the exact build instructions that were used to construct the package. There's a crucial feature that comes with build provenance, and that is a public transparency log. And this is for two audiences. First, package maintainers, so they can be aware of any time a new version of their package is being published and can audit and ensure that it is authentic and coming from their infrastructure. And second, for you, the skeptical black hat public, who can now audit that we are operating this capability of the NPM registry in the way that we are saying. All right, we've reached the juicy center of the presentation. So we're going to walk through the data flow diagram of how build provenance is provided. And we're doing this so that you can have that one layer beneath that sort of like surface level overview to really absorb the techniques and see how you might apply this to your own work. If we wind the clock back 2-3 years, cloud CI/CD providers started providing a new feature, this signed OIDC token for workload identity. Initially, this was intended so that once your build was done, you could assume into a cloud provider. You could upload your build. You could run a deploy on cloud infrastructure. But a lot of the properties in that OIDC token are the exact same properties that we're talking about with build provenance. So as we walk through this data flow diagram, this is all being driven by the npm publish command with the -- provenance flag that we added. The first thing that happens is that it requests that signed OIDC token. Then there's a security feature that kind of comes along for the ride. We generate a public-private key pair. We sign the build with the private key, and then we throw the private key away. That's a bit unconventional, so I'm just going to emphasize When you use build provenance, you can sign your software builds without having to durably manage key material. No more worrying about how to securely store it, if you need to rotate it to an incident, or if someone leaves the team. You sign the build, you throw away the private key. And the reason that you can do that is because you then take that assembled information, the OIDC token, the signature over the build, and the public key, and you send that to the Sigstore public goods service. There's two separate components here, and first we're going to talk about Fulcio, which operates as the signing certificate authority. This is really analogous to like Let's Encrypt, except instead of talking about HTTPS certificates, we're talking about code signing certificates. But they're still X509, and we burn into the OIDs of that X509 signing certificate the properties from the OIDC token, the public key, the signature over the build, et cetera. The second part of the Sigstore public goods service is Recore, the transparency log. So we assemble the facts of the build, and we submit that to the transparency log so that people are aware of what's going on. We are finally ready to publish our package. Just as before, we sent the package to the NPM registry, but now we have some extra information along for the ride, the build provenance information and the signing certificate. And then there's another crucial step here where this whole system is about transparency. And so when the NPM registry receives a package with provenance, it also publishes to the transparency log. And again, this is for package maintainers to ensure that new releases are authentic and coming from the intended source, as well as allowing the whole public to monitor the operation of the registry in this way. I know that was a lot. We're going to pull back and bubble up one level and talk a little bit more big picture. So in this presentation, we use we a couple of times. This is not some system that Trevor and I just made up as we went along. This wasn't even something that the teams at GitHub and the teams at NPM who worked together to implement and deliver this feature made up. There's a variety of open bodies that have been writing specifications that this system conforms to. So we have the SALSA specification for supply chain security. They specify those specific build facts, the links to the build instructions, the links to the source code, that sort of thing. When you assemble those build facts into a document, that document comports to the in toto specification. And then, of course, we talked about the Sigstore public goods service, which operates both the certificate authority as well as the transparency log. All of these groups are part of the OpenSSF, or its parent organization, the Linux Foundation. The Linux Foundation is a very broad umbrella. It includes the Linux kernel. It includes the CNCF and Kubernetes. Just to be clear, we're not on the scale of Kubernetes here yet. However, all of these groups meet in the open, and they're comprised of open source maintainers, academics, and people from private industry. Please come join this effort and help us support getting build provenance out to the wider world. Before I invite Trevor back up on stage, two other quick points. Trevor got his big proclamation, so I would say my proclamation is that security is only as useful as it is usable. We took pains to make this as easy as possible for NPM package maintainers to adopt, and I think that's why we've seen so many packages adopt this on such a short timeline. Once you've put your package build in the cloud, the only thing you need to do is take that npm publish command and add the -- provenance flag. We really want to make it as easy as possible for people to fall into the pit of success and enable new security capabilities. And then if there's one piece of homework I can give you, do check out the transparency log. So you can either get to this by going to the NPM website. Earlier we showed the semver package, and if you scroll down past the README, there'll be that provenance section, which contains a link to the transparency log. Or you can go to search.sigstore.dev and search for entries from there. There's a ton of information that's included in build provenance. It does not all fit on a slide. So please do check out the transparency log. Look at one of those attestation documents, and you'll see all of the different information that we're providing that you can then use to make these more informed risk decisions. And with that, I'm going to hand it back to Trevor.
Thanks, Zach. This is a safe space, right? Yeah? Well, I'm just going to go ahead and admit it. I find security kind of depressing sometimes. And I would think that if the people in this audience don't, you're probably lying. Or if you say you don't. It can feel kind of overwhelming, right? There's so many attackers. There's so much threat surface. There's so many threat actors just sort of constantly multiplying. If you work in incident response or you work trying to figure out root cause of some bad breach, it can feel like you're sort of navigating your way through a forest of mirrors. What I really like about Provenance is that it offers a chance, as I said at the top of the talk, to get a bit more certainty, a bit more concreteness into the flows that we all have to work with as people who are trying to practice this art of defense. And so, make no mistake, what we are looking for, what we are advocating, what we will be pushing for is a strong cultural shift towards expecting to know where the things that you're using are coming from. And that will extend eventually not only across open source ecosystems, but into proprietary code, into the things that you might be building internally. But getting there, doing this cultural shift, is going to take a big change in some of our assumptions and some of our existing practices. And some of those might feel a little bit controversial to the open source community. So I want to walk everybody through those now because it's very important to get on the same page about this. The first one, as Zach alluded to a moment ago, is that we have to completely throw out the existing signing paradigm for open source software. I know a lot of people probably saw that slide before and they said, hey, wait a minute, this looks really elaborate. We have had signing in most ecosystems for open source packages for years. And that's true. In almost any registry you can think of, you can sign your thing and you can upload it with a signature document and then somebody can pull it back down and they can verify it. Well, they can try to verify it. The problem is this is almost all the time based on PGP. And PGP was developed basically to make it easy for human beings to have a way to communicate with each other in a trustworthy manner. And it has this concept called Web of Trust. It doesn't do PKI. It doesn't try to solve the problem of how to get a key that you can definitely trust. It says, no, human beings will meet up in real life. They'll decide they trust each other. They'll exchange keys. They'll kind of sign over those keys. They'll upload them to some key server somewhere. And then, cool. If I maintain, libfoobar, then I can sign with my PGP key and I can put it in the cloud. And then, oh, wait, I don't know. How do I tell somebody that I'm definitely the maintainer of libfoobar? It's kind of rough. I want to just make sure that we're all on the same page about stopping using PGP for signing. PGP in general, let's be honest, it needs to be sent to a lovely, beautiful farm where it can run and play with other outdated crypto protocols. It's just time. There is no meaningful way to verify whether or not an open source library signed by some random person is definitely has the validity of trust that you would expect. So at the risk of breaking the cardinal rule and reading a slide, I will just jump up and down on this. We need a paradigm that does not require verifiers to strongly identify individual human beings at a given point in time. We need a paradigm that doesn't require maintainers to deal with durable private keys that can be easily stolen, and that would be a catastrophe, or can be lost, and constantly are. Or that are predicated on ridiculous tooling like GPG, which I don't know about y'all, but anytime I've ever tried to do anything with GPG, I've forgotten, and I've had to Google, and for some reason you can't actually find it, and so you end up on like the University of Hawaii's CS department webpage where there's like cryptic commands and you copy and paste. And this is not security, this is theater, right? We need real security. And finally, we need to distribute some of the trust outside the closed loop that takes you from package manager client binary to package manager server and back, and never involves any other system in the trust process. So that's the first conclusion. Let's rethink signing. The second one, and this is the one that is most controversial because of what it implies, is that something really can't be thought of as open source unless, well, more than just the source is open. We talked earlier about how we have source code repositories and registries, right? We need to see things built in the open. The process by which that source code is transmuted into the finalized artifact that you actually pull down and build has to be open. Otherwise, the model breaks down. Here, what you're looking at is some of the documentation from Fulcio, which is Sigstore's certificate authority component. I want to focus in on the first two claims. The first one is an issuer, which uniquely identifies the integrating CI system that actually produced the OIDC token. The second one is a fully qualified URI to the build signer, the actual script that's getting executed on that system in order to create the thing. With these two pieces, we have a public declaration of the place where this was built and the actual thing that it was built with, right? Now, to get into a little bit more of like why people think of this as controversial, it's basically summed up in this question. Okay, and I think that here at a security conference, most people probably know the answer to this, but at a dev conference or on the internet, I see this guy a lot, some version of this guy. He's a little bit mad, he's a lot self-righteous. He wants to know why I'm calling his security practices on his laptop insufficient. He wants to understand why he has to stop doing exactly what he's always been doing, which is just building the source on his laptop and yeeting it into the cloud and saying, trust me, here's the hamburger. Yeah, well, I think we all know the answer here at Black Hat, but at the risk of being obvious, you can't build on your laptop because it is impossible to reason about the security posture of a private asset. It is impossible for me to know whether or not I want to trust the process that created this thing if I can't see the process. Let me reiterate. I can't trust your build if I can't trust your process. And I can't trust your process if I can't see it. Does this mean building on some kind of vendor system? Yes. And if you have a shrine to Richard Stallman in your house and you say, no way, never, I'm not going to build on, Circle CI or GitHub Actions or BuildKite or GitLab pipelines or any of the other things that offer a free tier and free compute because that's just against your philosophy, that's fine. This is optional. We are not going to be forcing people to publish with Provenance. But we will be doing what we can to affect that cultural shift, to try to make sure that over time, this just becomes expected. The next conclusion we've come to is one that we kind of touched on a little bit, but I think, again, it's worth emphasizing. And that is that machine identity is really the aegis under which we should be issuing signatures, not human identity. Okay? Now, if you think about this for a second, it's obvious because you should be verifying things that are signed, right? Otherwise, what's the point? And there is no way to programmatically verify whether it's Dave or Sally or Prashant or whoever that is actually the maintainer of libfoobar this month. It's not possible. There is no like universal human event bus where you say, hey, I've been hit by a bus and I'm not on the project anymore, or hey, blah, blah died and they're not on the project anymore. There's no way to consume this knowledge, right? You could see a key signed, you could see a package signed even by a maintainer that you know is indelibly associated with the project, right? Like Linus or the curl guy or the SQLite guy, right? There's still some personalities even in 2023 that are like indelibly associated with open source projects. But I don't know for certain how to find their key or whether or not that key is still valid, right? As we talked about before. So moving away from human notions of identity and towards a workload and machine-based notion is the only way that we can create programmatic verification that is in any way meaningful. This is where provenance needs to come from. The fourth conclusion brings some of these concepts together, and that is that provenance needs easy verification. It needs to be simple to do this, and it needs to be fully fledged. When you issue this command, both attestations are interrogated. The build attestation that comes from the CI system and the publishing attestation that comes from the package registry of record. Both of those two things are taking the package tarball, they're computing the digest, and then they are creating an attestation of those two, and this is making sure that that package digest is the same in each attestation. This is how we take that dotted line that describes a gap of implicit trust and turn it into a solid line that describes an ironclad paper trail between the two. There is no meaningful signing without verification. As I said, we've had signing in open source for a really long time, but it's mostly theater. Again, I want to end by talking about what could be if we can get to a world where provenance is universal. We think that working with the open source communities that we have the most influence over, and in this case that's NPM, is a great first step. But you'll be hearing from us and from others in the ecosystems more and more about provenance in the coming months and years. And our ask to all of you and to the folks that you work for is to adopt it, to accept it, to expect it, and finally, to demand it. You are a vital part of a huge cultural shift towards knowing for sure what we are building with. Once we are in that world, we will all have just a little more certainty. Thank you very much. We will now take questions, and we're going to leave this slide up here so that folks can copy down these lengthy URLs, because we would love to have as many people as possible involved in this effort. I should also underline something that I think is maybe not totally clear from our slides, which is that you do not have to build your NPM package on GitHub Actions. The Sigstore public good instance will integrate with any CI provider that meets 2 criteria. And that's a free tier for open source compute for open source projects, and the OIDC claims need to be there in the tokens that they mint. And if you have those, then we, Sigstore, will do the work to ensure that that system will work. Right now, there are packages on NPM that are built by GitLab Pipelines, for instance, as one of the early partners, and we have some other folks involved in integrating with Sigstore CI as well, or Sigstore CA. So I just wanted to make sure that's known, lest anybody think this is like a stalking horse for GitHub Actions.
Thank you.
Thanks, everybody.
We have about 13 minutes for questions.
That's right. And we could do more after, but yes, we left some space in the slot time here.
Thanks for the presentation. I'm Gary Belvin. I used to be on the Google Certificate Transparency team, so apologize if this is going to be a nerdy question. But just at a very high level, how would this have prevented some of the attacks that you demonstrated on the early slides?
Should be. Well, I guess what I would say is that there's a difference in mandate between registries. Some registries are deliberately open to the public and have a mandate that they can accept any contributions within minutes. These are your PyPIs, your Ruby gems, your NPMs. Then you have other registries which are curated, like Homebrew, apt, and they have people who vet the contributions before they're published publicly. We do not, we're crossing one of the gaps of trust here. We cannot tell all of the open source package managers of the world, hey, this mandate you had to accept any publish within minutes, that doesn't exist anymore. What we're saying instead is you can publish, and now we have this verifiable links to these information so that the people who use those packages can make a more informed risk assessment.
Yeah, and I would also add that in the event of like an account takeover on the NPM side, then you can see that something can be published that lacks provenance that was there before, and that will cause warnings in the UX, and it will cause warnings if you were to issue the NPM audit command as well. So as we all probably know, NPM depth trees are really big, or sorry, Node.js depth trees are really big. You know, the average Node.js project has something like 1,200 dependencies in it, and we don't have any illusions that this is going to be adopted overnight. This is just giving a breadcrumb trail, if you will, that has never existed before. So we believe that it's axiomatic that there should be an assertion that is trustable about the origin of something, and those can mitigate some of the attacks that we've talked about in the case of an actual registry compromise, right? Obviously, if you compromise the originating build system, then you can feed things through this and you'll get provenance on whatever the compromised code might have been. But this is definitely giving another piece, as I keep saying, a bit of certainty that allows you to start to reason about where these things are and give you kind of an early warning.
So knowing that, hear me all right? All right? Knowing that we have our own registries and they're distributed, how is this information going to sync? You know, I mean, if we build and publish our own, how are the third-party or open-source libraries going to sync with our registry, for example? Will we have that type of capability to pull down?
Absolutely. So one of the things I should have made more clear is that when you send the provenance information to the NPM registry, it makes it available over the web UI, over the API, and the CLI. This information is very cacheable. There's a one-to-one mapping between a package at a specific version and its associated provenance.
Build off that real quick. Is there any chance that this could be expanded to also show the latest scan or maybe some form of assessment in the fingerprint?
Yes. If you are not currently familiar with the Salsa framework, definitely check it out. It's undergone a little bit of a transition where in the 0.x versions, it attempted to cover the entire SDLC. That ended up being a really big bite of the hamburger, if you will. And so instead, in v1.0, they scaled to just talk about builds, provenance. But as the framework matures, we're going to expand to other aspects of how sources developed, how other dependencies are incorporated, scans or other checks that happen at build time, that sort of thing.
Thank you much.
Hi. If I understand this correctly, this moves the implicit trust to the CE/CD platforms. Is there some way to, with the npm audit command, to give maybe a allow list of trusted CE/CD platforms that are trusted by me?
Yeah, that's something. So this is still in public beta as we tweak some things like that. So one thing that's a bit of a gap for me as of right now, you have to just kind of know that you can curl a particular URL of, that's kind of an extension off the package's URL and acquire the attestation document itself. We're going to make that a little bit more user-friendly so that you can kind of pipe that toward some kind of policy engine, right? So if, for instance, you wanted to write like a rule in Rego or Q, and you wanted to say, I have defined a collection of sources that I trust, whether it's a CI provider or an organization or a repo or collection of repos. This is something that we want to enable, but creation of policy is sort of outside of the bounds of this particular thing. But making it simple to just sort of pipe it over and allow you to hold a collection of policies and easily apply this to those is something that's definitely on our roadmap.
Okay, thank you.
Cool. Any other questions?
Could you explain the relationship between this project and like reproducible builds? By which I mean, if we have these documents about the CI/CD saying what it did, do we have any examples of when the registry is not being honest? And if it wasn't honest, is there an expectation in the transparency ecosystem that people will be taking these documents and trying to reconstruct whether the build was in fact legitimate?
Can I take a stab?
Yeah, go for it.
Yeah, so we are definitely not claiming, even though I did sort of jokingly, that we've solved all supply chain security problems for the entire open source ecosystem with this presentation. We are focusing on the NPM ecosystem and providing these specific links of here's the source code, here's the build instructions. Other supply chain efforts like reproducible builds, I think, are a welcome other pillar to hold up the roof of supply chain security that we're kind of being crushed by right now. There are also primitives that can be reused between these two things, like transparency logs or gossip protocols between reproducible build systems. I don't want to throw shade, but this is a capability that's live today. There are ongoing efforts and ongoing challenges with reproducible builds. I hope that we realize that dream.
Yeah.
But part of the reason we undertook this work is in the meantime, we want other related security capabilities.
Yeah, and to add to that, reproducible builds are really ecosystem by ecosystem. You can get them in certain places and not in others. I was part of a pretty famous response to a pretty famous supply chain attack. And there was no way to make the thing that was attacked reproducible at the time because it was based on .NET, and at the time there was no reproducible flag with MS Build, right? So I think that's been solved now, but like, even if you go back and you look at the old version of Salsa, like 0.2, and it would kind of tell you that, you know, the final level, the final boss of Salsa, level 4, is like hermetic builds that are fully reproducible, and there's an asterisk next to fully reproducible because it's basically like, does this technology allow it, right? So in container ecosystems, of course, there are certain things that are, you know, if you want to build a fully reproducible Docker image with BuildKit, you can't. With some other technologies that come from Google, like Co and things like that, you can, right? And so I think, or Canico, I guess is what I'm thinking of. We love the idea of provenance being everywhere, as we've said, and I think that eventually, yes, if you want to use this as a basis to compare whether or not you've achieved strict reproducibility, the toolkits that we imagine would make that easier. Hopefully that answers your question. Anybody else? I think.
Also,
oh, he wants okay.
yeah, also a quick question. So in here, so how would be this framework helpful for developers? Like from security perspective, we can just pull the signature logs or to the dependency. But if if in the developer's perspective, are we trying to integrate this to NPM to pull as part of dependencies? So instead of rather they're pushing their own private or open source code with a hash, or we can also pull from Sigstore.
So you're asking how this can help developers through the, in the process of sort of selecting dependencies, or?
Yeah, not like in a regular basis, like a developer or security person need to push the code and check it every time, but as part of the pull of the Maven or NPM, whatever we have. So is it a way to also validate that rather than Provenance?
Yeah, I think if I was looking to incorporate this into my workflow, hopefully I have some system by which I am considering new libraries, new dependencies that are being introduced into my code base. And so at that time, if the system that you're using supports provenance, then you can use this as sort of an additional input to evaluate that. I think there might have also been a question in there about how we get this to more systems and more registries. And that's something the OpenSSF Securing Software Repos working group is working on, but it's going to be a journey.
If you see this top link here, this is kind of like a manifesto of sorts that basically describes a way to move forward and do this for pretty much any packaging ecosystem, right? So we've been spending a lot of time talking with folks from PyPI for Python, Ruby Gems, Cargo for Rust, Maven Central for Java. There's a lot of interest in this process and moving in this direction. It is definitely something that our team at GitHub works with the rest of the ecosystem to do. And so we feel pretty confident that this kind of thing will extend further out into the open source world over time. And you know, it's going to take time though, right? As I said before, you know, specifically in the case of Node.js, we're talking about tremendous numbers of dependencies. And so it really will require folks who are grabbing something to start to use it, to start thinking, aha, does this have provenance? If so, I feel like I can trust it a little bit more than something that doesn't. And those are kind of the first steps towards that world.
I see that our time has gone yellow, and I'm getting some hand signals off stage. So I think we're going to continue the conversation in the breakout room.
Yeah, there's definitely a Q&A room that we will be shepherded to here in a moment, and you feel free to follow us and come ask. But thanks again, everybody.